Hello friends, now today this is very important lectures. So today we will solve the cat 1 all the problems and we will try to finish this is with minimum time, and we will also show you how to write the questions during the exam. So in this lecture we will cover the linked list, we will cover the heap tree, BFS, DFS, complete binary tree, array, stack, queue, priority queue, minimum spanning tree, binary search tree, heapify method, Kruskal and Prim. Okay. So now this question we asked, the first question was we asked, this is the first question. So in this first question we ask, we have given you two figure number 1 and figure number 2, and we are asking these are not equal. So why these are not equal? So now we will try to explain why these are not equal. So now see here, we have solved all the question to reduce the time during exam. Okay. So now this is the first one. This is the figure number 1. Okay. And this is the figure number 2. Okay. What we have given you. Now if you know the linked list, so we have created 3 nodes. Let the address of first node is 2036, address of second node is 2040, and address of third node is 2044. So according to the property of linked list, the address of this will be here, the address of this will be here. Okay, according to this figure I am just saying. Now this figure you can see there is 2 arrow number, first arrow is this, second arrow is this. So according to this I created this figure. Same also here, the address of this is 2040, 2036 and 2044. You can write anything. So according to this, so the address of this will be here, the address of this will be here. Okay, according to the figure. So what is the meaning of this? This is taking 2 address. First is the right and second one is the left. It means that there are 2 pointer. There is only 1 pointer. It means that this is singly, this is doubly. So in exam you should write only this one. This is singly and this is doubly. Enough. Question number 2. In the question number 2 we asked 5x square plus 2y plus 7x square. How many data types, pointer and nodes are there to represent the polynomial? So this polynomial, the first one is the term, second one is the term, third one is the term. Term means node. This is the first node, this is the second node, this is the third node. Now according to the property of linked list, you will write some address for this node, and for this node also. The computer will create. Okay. Now the address of this will be here, the address of this will be here. So now you can see after then there are, one is the coefficient and second is the power. One is the coefficient and second is the power. So according to this, in this node, one is the address means pointer, and second there are 2 data type. One is the power and second is the coefficient. So according to this question you will write in your exam, coefficient is equal to 1 means total data types is equal to 2, and there is 1 pointer, and total number of nodes are 3. Okay, this is the correct answer. Question number 3, he is asking what is heap tree. Heap tree is the complete binary tree. Just after some time I will explain why it is complete binary tree. Now next one is we are asking about the BFS. BFS means binary. This is the breadth first search and this is the depth first search. So what is the breadth first search? Okay. What is the breadth first search? So BFS means Q. So Q, and we will use Q on by the help of this property, means we are using the method that is the FIFO, first in first out, and in DFS we are using stack, and stack, it is the concept or the method is LIFO, last in first out. So in DFS we are using stack, in BFS we are using Q. Okay, this is very important for the placement purpose. Okay, now next one, we are asking the fifth question. If they have given you this graph, this is a graph. Now how many possible tree, minimum spanning tree can possible? So the first one is this one. What is the minimum spanning tree? If they have given you one graph, so now in this graph you have to remove any one edge to make it tree. Now you can see, if I will remove this one, then after then, if I will remove this one, then after then one tree is this one. If I will remove this one, this is remain. If I will remove this one, then after then this is another tree, this is another tree. So there are total number of 3 possible tree if there are total number of 3 nodes. Now second question we asked, if there are total number of 4 nodes, then how many possible tree? You can see also, I will remove only one edge, any one edge I will remove. This is the first one, this is the second one, this is the third one, and this is the fourth one. So in the GATE exam they are asking, if there are total number of n nodes, then how many possible tree, minimum spanning tree. Okay, we also explained this in the previous video. Now in the question number second, what they are asking, so in this question we are asking, write the main difference in array, Q and stack. Now see here, okay, I will write here better. So now array, what is array? Array means I will draw one figure. This is the figure. I am writing something here. Okay, suppose I am writing here, I will use another color. I am writing 1, and here I am writing 2, here I am writing 3, here I am writing 5, here I am writing 7. So what array size is fixed. Okay, now this is the main. So whenever you are giving any interview, at that time you should also tell them, if you are using array is static, number first, array is static. Okay, and second, if you want to delete this 3, suppose you want to delete this 3, so if you want to delete this 3, what you can do, you will shift the element. At first you will go from this position to this position, then you will shift this element from here to here, then here to here. After then your array will be like this. This is the first element, then second element, then fifth, then seventh, then after then this is 7. Okay, so after then the sizes remain same. So what is the meaning of this? Whenever you are deleting any single element, the time complexity will be order of n. This is the biggest problem in an array. But now if I am talking about the stack and queue, okay, now see here, this is a stack, I am using a stack now. So this is my stack. Okay, stack means I am using the LIFO. Okay, this is my first element, second element, third element, fourth element. If I want to pop, at first I will pop 4, then I will pop 3, then I will pop 2, then I will pop 1. So this queue and stack, it is based on the dynamic memory allocation. Number first, you should remember. Okay, don't use the static, it is dynamic memory. Now you are using the FIFO or LIFO method in queue and stack. Now if you want to delete, suppose you are using array also, okay, means just like dynamic memory allocation, and the data is suppose 1, 2 and 3 and 4. So this is my first data, this is my first data, this is my second data, this is my third, and this is my fourth data. So according to this, at first I will pop the last one, then I will pop this one, then I will pop this one, then I will pop this one. So if you want to delete any element, suppose you want to delete this one, you can directly delete. But if you want to delete this one, then you will pop all the element, then at last you will delete this one. So here also time complexity order of n, but sometime order of 1 also. Same also in Q also. If you will go in Q what you are doing? In Q, this you are using first in, first out. So who will come first, that will be delete. Who will come first, that will also out at first. First in, first out. Okay. So this is the main difference between array, queue and stack. I observe many people, they are writing some absurd points during the exam. They are trying to fill the exam and fill the copy. So this is not a better way, because you are preparing for the placement. Now next question I observe also. In the next question I ask, question number 3, you can see I asked, I want to know how many people they are learning. So what I did in this question number 3, I have given total number of 5 process and total priority is equal to something I have given. But to confuse you, I have given arrival time and burst time. So you people, I want to see how many people they will go to the operating system. So now you can see, whenever there is a arrival time is same and burst time is same, in this condition there is no effect here. Okay, in this condition you will never think about the primitive or non-primitive. Okay, because the burst time and arrival time is same, means either you write this arrival time, burst time in your node, or if you are not writing, there is no meaning, because burst time and arrival time both are same. So in this condition, what you should write during the exam? Now see here what we have written during the exam. During the exam you should only draw the figure. Okay, so now during the exam the first priority is equal to first priority means 0. So 0 I place here. Then second priority is equal to 1 I place here. Third priority is equal to this. Third priority is equal to 2 I place here. Then 3 I place here. Then 4 I place here. Means 0 means P2 I place here. Then P4, then P1, then P3, then P5. Only this one, only 30 second or maximum 1 minute question. I wanted to check how many people are intelligent in my class. So I have given the question, but I observe there are more people, they have written the operating system solution. So this is not a way to learn. Okay. Now sorry for that. Now next I will come. I wanted to also to try to check how many people they are learning the coding. We also explain this code during the class also. So in this code, that is you are creating total number of 5 nodes. You can see also here. This is the code. You are creating total number of 5 nodes because n is equal to 5. This is a creation. You are creating the node. Okay. So this is a very famous code. We explain also in exam. You are creating one P. There are total number of 3 pointer. One is head, one is PREB, and another one is PREB, another one is PREB and head. Okay, so this head. So you are creating total number of 5 nodes. So during the exam you should write only this one. Okay, you should write only this figure, and there are some people they have written this figure, means the figure is representing you are creating total number of 5 nodes. So whenever you are writing any node, at that time you should also write the address of each node. You can write anything, no need to write 2040 something. Okay, you should write these are the address of our nodes. Now next we are asking about the BST. We have given total number of some data. The first one is 45, then 15, then 79, then 90, then 10, then 55, then 12, then 20, then 50. Now we are asking to you, please create the binary search tree. So according to the binary search tree, at first I have taken 45, then I am taking 15. Now at first you will check 15 is less than 45. Okay, it means that 15 will come to the left side. So I have written 15 at the left side. Now the second element is 79. So 79 will ask to the root. 79 will ask to the root. So 79 is greater than 45 means 79 will be come to the right side of 45 because it is greater than 45. Now next data is equal to 90. Now when the data is 90, this 90 will ask to the root. It is greater or smaller. It is greater means you will go to the right. Now again 90 will ask to the 79. 90 again it is greater, so it is the right side. So 90 will be placed at the right side of 79. Now next data is equal to 10. This 10 will ask to the root. 10 is less than 45, so you will go to the left side. Again 10 is less than 15, so you will go to the left side. So you can see this is the diagram of my BST. Okay, or after then next data is equal to 55. So now 55 will ask to the root. 55 will ask to the root. 55 is greater than 45, so I will go to the right side. Now 55 will ask to the 79. 55 is less than 79, so you will come here. So this is the structure, this is the diagram. Now next insertion is 12. Next insertion is 12. 12 will ask to the 45. It is smaller, you will go to the left side. 12 is less than 15, so you will go to the left side. Again 12 is greater than 10, so you will go to the right side. So this is the diagram of my binary search tree. Now sorry for that. Now next data is equal to 20, means you have to insert 20. Now again 20 will ask to the root. So every time you are inserting the data from the root. Later we will show also how the code is working. So 20 is less than means you will go to the left side. 20 is greater than 15 means you will go to the right side. Okay, right side of 15. So this is the structure. Now next data is equal to 50. So 50 will ask to the 45. 50 is greater than 45 means I will go to the right side. 50 is less than 79 means I will go to the left side. 50 is less than 55 means I will go to the left side. Now this is the overall structure of my BST. Now I have to delete root. So what is the root? Root is 45. Root is 45 means now there is a one tree, that is the left subtree. This is the left subtree and this is the right subtree. This is the right subtree. So what is the definition? If you want to delete the root, then, or if you want to delete the node which has total number of 2 child, in this condition either you will take the smallest element at the left, greatest element at the left subtree. This is my left subtree and this is the greatest element. You can see that 20 is the greatest, 15, 10 and 12. 20 is greatest. Okay, and either this one or at the right subtree the smallest element. The smallest element is 50. So 50 is smallest, then 55, 79 and 90. So either take the smallest element, greatest element of left subtree or smallest element of right subtree. So I am taking this one. I will swap this and this. So if I will swap this and this, 50 will come here and 45 will come here. So here I have done one mistake. This is 50. This is 50. Okay, 50 will come here and 50 will come here and 45 will come here. So 45 will come here. So you will write 45 here. So you will write 45 here. After then you will cut this one. So this is the final structure of my solution. Okay, done. Now next question I ask, heap tree. So friends, now again we will discuss about the heap tree. So what I told, what is heap? Heap means it is a complete binary tree. Means you can see that we have here written here, we have written some nodes. So at first you will fill this node, then this is another node. This is binary tree, means maximum 2 child, either 0 child, 1 child or 2 child. That is the meaning of binary tree. So now at first you will fill this one, then you will fill this one. Okay, now see here, suppose then this node you will fill, 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 then this node you will fill. This is the way to fill in complete binary tree. If you are not able to understand, I will show one example. Can I write here? Not possible. Okay, suppose you have total number of, some data. Suppose the data are 5, 9, 6, suppose only 3 data, and okay, 5, 9, 6, 2 and 3. Suppose you have this data 5, 9, 6, 2, 3. So how you will write? You will never think which one is greater or which one is smaller. At first 5 will come here, then 9 will come here, then 6 will come here, then 2 will come here, then 3 will come here. So you are filling the data from left to right, from left to right. This is the complete binary tree. So what is this? Every heap is the complete binary tree. Already we explained. Every heap is the complete binary tree. Now what is the meaning of minimum? Minimum means if this is a root, this is a child. Okay, this is a root, this is a child. In a tree, if the father means root, is smaller than child, it may be anything, any value. If the root, let root is equal to 5. Okay, if the root is smaller than father, if root is smaller than child, then this is the, you can see 5, this is 5, this is 5 is smaller than 12 and 19. So this is the minimum. And maximum means if father, this is the father means root. If root is greater, suppose root is equal to 12 and this is 2 and this is 3. If the root is greater than the child, okay, in this condition such tree is equal to max, means maximum heap tree. Okay, means heap means you will use complete binary tree, and minimum means every time father is smaller, and maximum means every time father is greater than the child. Okay, I think that you understand. Later we will discuss about the heapify method. So here at first, because we are asking in the exam, heap method. Okay, so I think that you have written the value in your copy. And okay, so now the first data was 45. So 45 I have written in one node now. So according to the property of complete binary tree, the next data is 15. So 15 you will place here. Okay, according to the property of complete binary tree, 15 will come here. Now 15 will ask this 45, which one is smaller, because this is the minimum spanning tree. Okay, this is the minimum heap tree. Okay, so if it is minimum means father is smaller. So now 15 is smaller than 45. So 15 will come here and 45 will come here. Okay, this is the heap tree, minimum heap tree. Now next data is equal to insertion 79. So if you are inserting 79, now you can see you will insert the data from left to right. Okay, so it means that the 79 will come here. Now 79 will ask to the father, who is greater and who is smaller. Father is smaller. Okay, no problem, because this is the minimum spanning tree. Father has to be small. Okay, now next insertion is 90. So this is binary. So binary means maximum 2 element. Done. Next element will come here. So next element is equal to 90. 90 will ask to the 45, who is greater and who is smaller. So father is smaller, no problem. Done. Father is smaller, no problem. Next insertion is equal to 10. So according to the binary search tree, the data will come here next. So data will be come here. Now this 10 will ask to the 45, means father. So 10, who is the minimum? 10 is minimum. So 100% you have to swap. 100% you have to swap. So 10 will come here and 45 will come here. Again this 10 will ask to the father. Now this is the father. So who is minimum? 10 is minimum. So again you have to swap. So this is the final structure. 10 will come here and 15 will come here. So now you can see that every time father is smaller. So this is the minimum heap tree. Okay, sometimes I am using this minimum spanning tree. Okay. I will tell why this is I am using spanning. Later we will explain. Actually this is minimum heap tree. Okay, now next you have to insert 55. So according to this property, you insert 90, you insert 45. So next data will come here. Next data will come here. Okay, so now it means that 55 will come here. Okay, 55 will come here. According to the complete binary tree, 55 will come here. So 55 will ask to the 79. Who is smaller? Okay, 55 is smaller. 55 is smaller than 79. So if 55 is smaller than 79, so what you should write here? Here I have done one mistake. So both they will swap. Okay, both they will swap. So what is the final structure? The final structure is equal to 10. This is 15. So my request in the PDF file, because I was working late night continue and I was not sleeping. So somewhere I have done mistake. So my request, please remove the mistake. So 55 will come here and 79 will come here. Okay, I think that you understand. Now next data is equal to 12. So 12 will come here. 12 will come here. So now 12 will ask to the father. Who is father? Father is 55. So you can see that father is greater. So both will swap again. This both will swap. So what is the final structure? So now again I will correct here. Again my request, please correct here. This is 55. This is 55. And this is 79. this is 79. Now 12 is smaller, so both will swap. So 12 will come here and 55 will come here. So here is 55 and here is 79. So this mistake I have done. Here is 79 and this is 55 and this is 12 is correct. Again this 12 will ask to the 10. Who is smaller and who is greater? Okay, father is smaller, no problem. Again you have to insert 20. If you are inserting 20, this is correct. 20 will insert here because this is already filled. Okay, this is already filled. 2 child. Okay, now next 20 will come here. So again this mistake, our again request, please improve in the PDF file. The correct answer is equal to 55 and this is the 12. Okay, now 20 is here. So 20 is smaller, no problem. 20 is smaller. So what is the meaning of this? Both will swap. So both will swap means 20 will come here. 20 will come here and 90 will come here. No problem. So now father is smaller. 15 is smaller than 20. No problem. Okay, this is correct. Now this is 79. Again this is mistake I have done. Okay, because continue I was working late night. Okay, now next you have to insert 50. If you want to insert 50 will come here according to the complete binary tree. So this is the final answer, 79. This is 79 and this is 55. Okay, this is 55. So 55 is this and this is 79. This is the complete answer of my problem. Now next question I asked, I have given you one figure. In this figure, this is the Kruskal method, and in this Kruskal method, I asked find the shortest distance. So there are two algorithms. One is the Kruskal and second is the Prim. These algorithms will work to find the shortest distance between the source and the destination points. Okay, this is the application of Google Map. Everyone is using Google Map. So inside one algorithm is working. So maybe it is Kruskal, maybe it is Prim, maybe it is Dijkstra. Okay, and there are other also Freud-Warshall algorithm, other algorithm. So here we are discussing about the Kruskal. So now this figure, how to solve the Kruskal method. See here, how to solve the Kruskal method. So in this question, this is the initial point and this is the destination point. So I am starting from the Vardhaman and I am going to the Sikandrabad. Okay, so how to go? Okay, this is the question. So according to the Kruskal method, you will start from here and you will check which one is the smallest. Prim will never work. Now next, Prim algorithm. How the Prim algorithm is working. Now see here, the Prim algorithm. So this is the first node. First node is V. I have to go from Vardhaman to Sikandrabad. So at V, at first at V. So at V, I will choose the smallest again. There are two route. One route is this, one route is this, and second route is this. Okay, which one is the smallest? This value is equal to 4 and this value is equal to 7. I will choose the smallest. I am going from here to here. Now I am at R, but this Prim will create also one stack, or you can say stack or queue or array, whatever you want to say. Okay, so and another one is the widget. So widget and minimum. Okay, there is a requirement. So space complexity will increase. So now what is the meaning of this? There are total number of two path. First path is this, second path is this. So the value of first path is equal to 4, the value of second path is equal to 7. So out of these two, what is the minimum? Minimum is 4. Means you are going to the fourth direction. You are going to the fourth direction. If you are going to the fourth direction, so from this array widget, you will remove, you will take out of this two, means these two paths, you will take the value where you are not going, means this route or this path you visited but you are not considering. Okay, this path you visited but you are not considering. So minimum is 4, means I am going this direction. Okay, now if you are going this direction, what is the meaning of this? I started from here and I am going here, I am now here, okay, this is my position. Now what is the meaning of this? Here I already visited 7, I already visited. Now in the second time when I will create the minimum, so how to write the minimum? When I will write the minimum, so this 7 will come second. So at R, how many path? First path is this, second path is this, third path is this. All the value of the path 252 I will write at here. Where? In the minimum. Now in minimum, out of this value 2257, which one is the minimum? Minimum is the 2. Okay, now either you can go this side or you can go this side. Machine is not human. I know if I will go from this side, then I will reach very fast. But machine is not human. So let I am going this direction. Okay, let. Okay. So if I am going this direction means minimum. This direction I am going. Now out of this, how many data in my visit? So let I am going this direction. Okay. So how many data in my visit? The first data in my visit is equal to 7. Second is 2. This already visited. Okay. So 7, 2 and 5. So total number of data in my visit is equal to 257. And here I already visited. Now next. Now add next. So now you can see I started from here and I reached here. Then I reached here. Okay, I reached here. Now minimum. Now at this point there are two routes. First path is this and second path is this. You can see also, if you have any confusion, I will show one thing. You should see the initial graph. At I there are only two routes. One is 9 and one is 5 and 2. Okay. So now see also here. At this point, one is 9 and one is 5. What I told, one is 9 and one is 5. At I. Okay. Now at I. So now minimum. So minimum total initially the visit was 257. So 257 definitely I will write from the visit. Okay, from the visit I will take the value in my minimum. So now next 5 is already here. 3 also I have written here. 3 also I have written here. And 9. Now out of 2, out of 5, 7 and 3 and 9, which one is the minimum? Tell me. The minimum is equal to 2. If minimum is equal to 2, and where is the minimum? The minimum is this. It means that now I will go this side. Now see here. So if I will go this side means I will remove this. Okay, I will remove this, and in my visit I am writing only some data. What is this actually? Now see here. This data will come from here. 5739. So sorry, 5739. So the data is equal to 5. I am writing this here. 5 and 7 and 3 and 9. This is my visit. Okay. So whatever the value I am removing from here, the remaining value it will go in my visit. These are my visit. Now You can also see. Now you can see when I reached here, I started from here, then I am going here, then I am going here, then I change my path, then I am coming here. Now at this point you can see, if I will go here, because there is also one direction at this point, there is also one direction, and any other direction, there is also one direction also here also. I am not writing here. One direction, two direction, three direction. Now see here. So from here, if I will go this direction, then loop will start, means circuit will start. If I will go this direction, then again circuit will start. If I have only one chance, means I can go only this side. So this value, this 3 I have to remove, and this value also I have to remove. What is this value? Go to the previous graph, this is 7. So this 7 also I will remove. Meaning is, this 7 I have to remove, and this 3 I have to remove from here. Why? Because these are making circuit when I am at the point M and I want to go another place. So what is the meaning of this? Now see here. So now I went from here to here. Okay, I went from here to here, then I went from here to here, then I went from here to here. Okay, now I will go from here to here. So what is the meaning of this? This place I cannot go, this place I cannot go, otherwise it will make circuit. Now I am here. I am here now. I am at H. Now I am at H. Now see here. Minimum at H, minimum. So previously visited was 5. Now there is only one line. You can see also, this line is the visited line, and this 9 is the visited. This 9 is the visited, this 5 is the visited. So 9 and 5 are the visited. Now what is this 3? 3 I removed. 3 I removed. Now 1 is the minimum. Okay, now means I am going from here to here. Now I am here. Okay, the meaning is this. Now so there is only one value, because now here, so at first I started from here to here, then I went here, then I came here, then I came here. Now I am at H. Now at H, now see here, at H. At H there is only one direction, this direction. Only one direction, this direction. There is no other direction. So from H I will go to S, and I will remove this 9. Why? Because it is making circuit. So I removed 9. So what is the meaning of this? I touch all the vertex. If I touch all the vertex, means this is my final answer. So total time complexity is equal to order of B square, because you are going to each vertex. You are also checking reverse also. Okay. So the time complexity is very high, and minimum. This minimum is equal to 14. You can see this is the benefit of Kruskal. In Kruskal, if I was going in Kruskal, you can see also in Kruskal the time complexity, means the minimum value was 4 plus 2 plus 1 plus 5. What is the value? 5 plus 1 6, 6 plus 2 8, 8 plus 4 12. So minimum value is equal to 12 here. In Kruskal I am getting minimum is 12. Okay, but in Prim the minimum I am getting 14. So according to my knowledge and my experience, the Prim is not good. You can see also the time complexity also very high, but Kruskal the time complexity is very less. So this is very important question. Okay, because multiple times we have seen they are asking in interview, if you are going for the PhD or any other exam or for the placement, so they are asking such type of questions. If you have any doubt, then please write in the comment box, and my suggestion, please study like this and also solve the questions during exam also like this. So 100% you will get the best result. Thank you so much.